All right, so we want to solve the following formulas for the indicated variable. So again, when we're steps to solving, I wrote them over here. We have goals. So what are we solving for? If we have to simplify our expressions, we'll do that. But then we'll isolate the variable term and then isolate the variable factor. So we're attaching terms and factors on both sides. But just remember, this is goal-oriented. And I'll just make this a little bigger. So let's solve P equals 2L plus 2W for W. So again, since we're solving for W, basically our goal is to get W by itself on one side. So we go back and we look at, right? We go back and we look at the expression that has W on the right side. We have two terms. So the first thing I'm going to do is to isolate the variable term on one side. So I want then 2W to be left on the right, isolate that. Well, in order to do that, I need to get rid of the 2L as a term. So I'll zero that out, and that means I need to attach a negative 2L term to the left side. So the left side becomes P, and then a negative 2L term. Okay, so I'm constructing this expression on the left. Last thing I want to do then is to isolate that variable factor. So I know I need to divide or attach a factor of 2 in the denominator, and that's what I need to do on the left side too. Again, the left side, I need to create a denominator of that whole left side. So the fraction bar needs to cover both terms, and then divide by 2. So the left side becomes an expression P minus 2L all over 2, and that equals W. Okay, so again, we're focusing on composition. We need to recognize the composition so we know what it takes to get rid of it or to accomplish our goal. So in this case, our goal is to solve for pi. So again, eventually, I want this to equal pi. So I go back up and I notice that this is one term and it's got factors of the 4/3, a pi, and a factor of r cubed. So if those are my factors, then I want to get rid of the 4/3 and the r cubed. So I can get rid of the 4/3 by attaching a factor of 3/4 to both sides. So on the left side, where I have this v, I want to attach a factor of 3/4. So again, that will cancel this 4/3 factor. Now I also need to get rid of the factor of r cubed. And again, if I do that, all I need to do is attach a factor of r cubed in the denominator. So the v, I'm going to attach a factor of r cubed in the denominator. So everything will cancel. And since everything was factors, we had to use canceling to do that. So I'll be left with pi when I do this. On the left side, I'm just going to combine these factors together into a fraction. So we have a fraction. The factors on top would be 3 and v, and the factors on the bottom would be 4 and r cubed. Okay, so we'll go to the next one. All right, let's look at this other one. We want to solve a equals p plus PRT for t. Again, our goal is we want to solve for t. Notice t is in this term here. So our goal is to get t by itself on one side. So the first thing we're going to focus on is the variable term. So we have two terms. Here's our variable term. So our first goal is to get PRT on one side by itself. So we can do that by zeroing out or getting rid of the P on the right. So we do that by attaching a negative P term on the left side. And then finally, to get T by itself, we notice we want to get the factors of P and R canceled. So this is P times R. When variables are right next to each other, they are multiplication. So I know on this side, I want to do the same thing. I want to create or attach factors of P and R on the left side. So to get T by itself, the right side would all cancel, leaving just T. The left side becomes an expression A minus P all over P times R, or PR. All right, so the last problem, this is something we're going to run into again in chapter 3, but we want to solve this for Y. So again, our goal to solve for Y, eventually, we want to get Y by itself on one side. So we start looking at the expression. So we have two terms, we have two terms on the left. Here's my Y term. So my first goal is to get just that Y term isolated. So I want this, and I notice I need to get rid of the 6x. So we'll attach a negative 6x term to both sides. And on the right side, I have a negative 6x and then plus 12. So the last thing I need to do to get Y by itself is to cancel this factor of negative 3. So again, I know that I need to attach the factor of negative 3 on the right side, and I need to write it under the whole expression in both terms. I need a fraction bar. So the left side will cancel with the Y, and so I end up with then Y equals, now I want to look at this negative 6x plus 12 all over negative 3. And I notice that this is the same, this factor of negative 1/3. We could create a factor in the denominator, or we could instead multiply that factor of negative 1/3, this fractional factor, times the whole right side. If I put that in parentheses, it would be negative 6x plus 12. So we could, like I say, instead of attaching it in the denominator, we could attach it as a fractional factor times, and then in parentheses. Well, this then would be distribution that we could use. And wouldn't this be the same as negative 1/3 times negative 6x? And then another term would be negative 1/3 times the 12. So again, I'm just going to go back. We distribute the negative 1/3 to both terms, and we could rewrite this. Instead of doing this, I'm not going to do the calculation yet, but negative 1/3 times negative 6x, isn't that the same as negative 6x over negative 3, a factor of negative 3, right? And the next term over, isn't that the same as a positive 12 over a factor of negative 3 in the denominator? So I'm just kind of showing you how to rewrite these things. But because we can write fractional factors in denominators as a fractional factor of like negative 1/3, then when I have fractions or factors in the denominator, I can distribute to each term in the numerator. And it is distribution, but the distribution is from factors in the denominator. So it's the exact same thing. So a lot of times what we'll do is if we have a factor in the denominator, we will distribute to each term in the numerator and then simplify each term. So y equals, well, here, the -3 cancels with the -6, leaving a factor of 2. So this would be 2x. And of course, 12 over -3, we could cancel, leaving a -4. Okay, so it's something we'll work on again in the next chapter too.